Hi, in this video we'll go through the basic features of the impedance analysis and fitting software that is available for download on GitHub. To run the software you need to open this executable file. This will open two windows. One is the GUI of our software. Let's start by taking a look at the basic features of the software by loading the example file that is also available for download on GitHub. This can be done by pressing the load existing file. In this case we'll select the YSC data or the impedance data of a YSC palette, and then we need to press run. This will load our data in this table, and the software allows to analyze and to calculate the permittivity, the dielectric loss, the electrical conductivity, the dielectric modulus, the impedance, the admittance, the modulus of impedance, and also the theta angle. Let's take a look at this basic the starting windows of our software. Basically we have three figures or three graphics. One of them shows the frequency dependence on the data for several temperatures. The second one shows the temperature dependence for all the frequencies of measurement, and the third one shows a 3D plot showing the dependence on frequency and temperature on each of the variable that we select to plot. This graphic is particularly useful when we have, for example, a dielectric relaxation, and you can see very easily the evolution of the relaxation as a function of temperature and frequency on a 3D graphic. We can change the color scheme of this graphic to any color that we wish, and we could plot this graphic and save it as a figure. We have also two buttons on the starting menu that say edit figure. In this case, this first one on top of this left graphic opens up a new windows where we can see the frequency dependence for all the temperatures. We can select the temperatures that we wish to analyze and plot the graphic. We can change the color scheme once again, the marker styles, and we can save this graphic either to an image file, or we can save the data to a text file. We can also plot this data as a waterfall graphic, and in this windows we also have two fitting options. One of them is the master curve, which is basically very useful to see the scaling behavior of the dielectric relaxation. Let's take a look at, for example, these temperatures where we have our relaxation well defined, and let's press the master curve. This graphic and data can also be saved by very easily by pressing this yes button. We can also choose to plot a YY graphic. In this case, it will show the real part and the imaginary part of the modulus. The second new windows, which is available on the starting menu, shows in a similar way the temperature dependence for all the frequencies of analysis. Once again, we can customize the graphic as we wish. We can save the data to a text file or to an image, or we can also create a new waterfall graphic. As we can see here in this section of the software, we also have the possibility to open and to calculate, to plot these Nyquist graphics, Nyquist plots. We can select the temperatures that we wish to analyze, and we can see the Nyquist plot of impedance, normalized impedance, dielectric modulus, permittivity, and also for the admittance. We can also choose to customize the frequency of our graphic. As we see here, another option available is the Arrhenius plot. As the name says, this basically calculates the Arrhenius plot for the conductivity of our sample. We can press this activation energy button and give two mouse clicks, 1 and 2 in this case, in these regions where I want to calculate the activation energy. It's worth mentioning that in order to these values to be accurate, the temperature should be provided in Kelvin. The two more advanced windows and fitting capabilities of the software are the Avrili-Aknegami analysis and the equivalent circuit model analysis. Let's just take a brief look at these windows, and we'll go through a little bit more with more detail of how to make fitting in these windows in future video. So we can choose the temperature, we can plot the graphic, and as we see here, we'll have three graphics. One, the real part of the function that we are plotting, in this case the modulus, the imaginary part, and the Nyquist plot. We can make the fitting of Avrili-Aknegami formalism to impedance modulus permittivity. We can also see the plot of the derivative method, and we can also make a fit to the loss tangent, just to take a look at what is the relaxation frequency in this formalism. There's several algorithms available for fitting, and we can fit up to 3 dielectric relaxations in combination with the DC conductivity term here. The other option that the software allows is basically to analyze the impedance data using equivalent circuits. There's a few circuits already available for choose to fit the data, and for example we can once again select the data that we wish to analyze and to fit, and we can fit the impedance either to the impedance data or the normalized impedance. Similar to the previous windows, we have more than one algorithm, and in this case we also have 3 weighting methods available. In the next videos we'll show some examples on how to use the software to perform impedance fitting.